Welcome back. I shall continue with the second part of the review. By the way, there is a chapter uh, in your book called Chapter P, stands P for prerequisites. It's a chapter that it has all the concepts that you need to review from algebra in order to be successful in this pre-calc course. So I will continue with the second part of the review. We'll talk a little bit about basic rules of algebra, uh, negation, inequalities, and so on. In the first part, I talked a little bit about real numbers. I talked a little bit about distance, absolute value, and inequalities. So in the second part, as I mentioned a second ago, we'll focus a little bit more in algebra. All that I'm saying in part one and part two of the review are on chapter P. So you should take your time and review everything that is in chapter P. This will not be part of homeworks, it will not be part of exams or anything like that. But you are responsible for actually knowing this information. It's all covered in a typical college algebra course. All right, so let us start. I'm going to share the screen here again. Bear with me. Okay. Again, review part two. We'll talk about basic rules of algebra. Okay. So, what are those? The so-called commutative rule. What does that mean? So whenever you add two numbers, the order in which you add the numbers, it doesn't matter. That's what basically this rule is saying. So if you add a plus b, is the same as adding b plus a. For example, 4x squared plus 1 is the same as 1 plus 4x squared. So whenever you add two or more things, the order in which you add them is completely irrelevant. That's what commutative property says. Commutative multiplication as well. Okay. So commutative multiplication, much like addition, if you multiply two things, it doesn't matter, two or more things, numbers in this case, or expressions, it doesn't matter the order in which you multiply them. A times b is the same as b times a. For example, when you multiply 3 minus x by x squared, that's the same as multiplying x squared by 3 minus x. It's exactly the same end result. Distributive property. Distributive property. So if I have a plus b and this is multiplied by c, this is the same as adding a times c and then b times c. So that's the same as a times c plus b times c. For example, uh, 2x plus 3 times 2y is the same as 2y times 2x plus 2y times 3 plus 2y times 3. We can simplify this a bit further. 2 times 2 is 4. X times y is x times y. 2 times 3 is 6. 6y. That's the distribution property. Additive identity. What do we mean by additive identity? That means, is there a number such that when I add it to something, I get back to that same thing? It's like adding nothing. Hence the word additive. Additive identity means the existence of a number such that when you add it to another number, you get that other number. What would be that? Well, hopefully we all know that the additive identity for real numbers is 0. That's the same as saying when you add 0 to a number, you get back to that number. Or it is the same as you haven't added anything, really. So a plus 0 is equal to a. For example, minus 5 plus 0, it's still minus 5. Uh, Associative addition, let's see what this means. Associative addition, it means that if you add 3 or more things, it doesn't matter which 2 you add first to the third. So the way you group the numbers in adding them, it's irrelevant. Let's see what I mean by that. A plus B plus C is the same as A plus B plus C. So whether you add A to B first and then add C is the same as adding B and C first and then adding A. That's what we mean by associative addition. Multiplicative identity. This means, is there a number such that when you multiply it to some other number, you get back to that other number? Hopefully we all know this is number 1. When you multiply something by number 1, you get back that same thing. So multiplicative identity is number 1. Minus 10 times 1 is still minus 10, for example. Additive inverse, minus 10 times 1. Okay. Additive inverse, what does that mean? Additive inverse. The existence of an inverse. Well, first of all, what do we mean by an inverse? If I have a number, what should I add to that number to get back to the additive identity? The additive identity is 0. So if I have a number, the question is, what should I add to that number to get 0? It is minus that number. That's the additive inverse of any number. So if a is some number, then it's if a is some number, then its inverse is minus a, because a plus minus a gives me 0, which is the additive identity, as we said before. Okay? Also, multiplicative inverse. If I have a number, what should I multiply that number by to get the multiplicative identity? Meaning, if I have a number, what should I multiply that number by to get 1? It is 1 over that number. So if a is a number, I should multiply one by 1 over a to get the multiplicative identity. So the additive inverse of any number is minus that number, and multiplicative inverse of any number is 1 over that number. So these are some basic rules of algebra. Okay, so what are some of the properties of negation and inequality? Not inequality, equality. Of course, you have seen these rules before, maybe not, maybe you don't know them with these fancy names. Nonetheless, you have done or you have used these properties, and you know these rules from before. So what are some of the properties of negation and equality? Okay. So if I have some number a and I multiply it by minus 1, that's the same as saying minus 8. For example, minus 1 times 8 is the same as minus 8. The negative of a number is always that positive number. Or minus 17 is the same as 17 or plus 17. A negative number times a positive number is the same as writing minus a times b, which is also the same as a times minus b. All these three statements say exactly the same thing. So, to which number you associate this minus when you multiply these two numbers is irrelevant. That's what this is saying. Whether you associate the minus with A or with the product or with B, it doesn't really matter. When it comes to multiplication, I have to make sure that this doesn't matter when you multiply two numbers. Okay, for example, uh, minus 5 times 4 is the same as minus 5 times 4 is the same as 5 times minus 4. The answer is still minus 20, no matter what. The answer is still minus 20. Okay, let's move on. Uh, However, if you multiply two negative numbers, situation is a little different. Minus a times minus b is always equal to a times b. So minus and minus always gives you a plus when it comes to multiplication. So, for example, minus 2 times minus x is the same as 2x. Okay, some more properties. Let me move on to the next page. Okay. Minus a plus b. Of course, it doesn't have to be just a plus b. It could be a plus b plus c. I mean, how many factors you add there, it's irrelevant. Minus a plus b, a plus b being in parentheses, it's the same as saying minus a plus minus b. For example, minus x plus 4, x plus 4 being in parentheses, it is the same as minus x plus minus 4, or as we customarily write, minus x minus 4, without the parentheses. Without the parentheses. Okay, so here are some other rules. If A is equal to B, then just like we saw with somewhat with inequalities, if you have an inequality, it's okay, or nothing changes The value of equality does not change if you add or subtract the same thing from both sides of this equality at the same time. So if A is equal to B, then A plus or minus C is equal to B plus or minus C, meaning it's okay to add the same uh, or subtract the same number from both sides of this equality. For example, for example, half plus 3 is the same as 0.5 plus 3. We know that half is equal to 0.5. Nothing changes if you add plus 3 to both sides of this equality. So let's see, this is the same. Half plus 3 is the same as half plus 3, 3 over 1. 0, 5, 0.5 plus 3 is the same as 3.5. Here you adding two fractions that have different denominators. So the common denominator is 2. I'll write a little bit more about this rule in the next few pages. So putting things on the same denominator, it is 1 plus 2 times 3 is 6 over 2 is equal to 3.5. So 7 over 2 indeed is the same as 3.5. If you divide 7 by 2, you'll get 3.5. So this is true. Here's the other rule. If the same thing but with multiplication now, if A is equal to B, then you can multiply both sides of this equality by the same number and nothing will change, meaning the value of equality will remain the same. For example, you know that 4 squared indeed is equal to 16. This is the equality. What happens if I multiply both sides of this by the same number, namely 2? You get 32, and 32 really is equal to 32. 4 to the 2 times 2 is 32, and so is 16 times 2. So that also works. Here's another rule. If A plus or minus C is equal to B plus or minus C, then it must be true that A is equal to B. It's, so to speak, the reverse of this. So if this is a given equality, from this equality, it follows this other equality. That's what this is saying. Okay, so it's the opposite of this. Here's an example. Let's say that you are given that half minus 1 is equal to 0.5 minus 1. You are given this. This is equality. From here, according to this rule, it must be true that half actually must be equal to 0.5, and we do know that this is in fact true. Same thing goes with multiplication. So if it is given to you that A times C is equal to B times C, then it must be true that A, it has to be equal to B. Here's an example. And we use this a lot of times in solving equation. Sometimes this is known as saying you cancel C from both sides. I mean, it's exactly the same property, but you use a slightly different lingo, or you have used a slightly different lingo in your previous college algebra course. So that's the same as saying you cancel C from both sides, and it remains that A must be equal to B. And as I said before, we use this property a lot when it comes to solving equations. So if you are told that 3 times x, it is equal to 3 times 4, or if you are told that 3x is equal to 12, and 12 is the same as 3 times 4, then this must imply that since 3 is the same on both sides, much like the property I just listed, you cancel C, or you cancel 3 in this case, and you say that X must be equal to 4. That's just one way of solving this simple equation. Okay, further, properties of 0. What are properties of 0? Properties of number 0. So whenever you add 0 to a number, as we saw with additive identity, you get back to that number. Anytime you subtract 0 from a number, it's the same as getting back to that number. Anytime you multiply a number by 0, that will give you 0. Anytime you divide 0 by a number, you will get back to 0. Keep in mind, division by 0 is undefined. So a divided by 0 is undefined. You probably know this, and you know it as a rule that you cannot divide something by 0, but the question is, why is division by 0 undefined? Let me just give you a simple numerical example. We know that 6 is equal to 2 times 3, right? And because 6 is equal to 2 times 3, we also say that whenever we divide 6 by 3, we get uh, that 6 divided by 3 is equal to 2, because 3 times 2 here is equal to 6, and 6 minus 6 is 0, right? We know that. So if you write 6 as a product of 2 and 3, it means that 6 is divisible by 2 and 3. Okay, so if you say 6 divided by 0, here you just said 6 divided by 3 is equal to 2, right? That's exactly the same. We're saying the same thing here. So what does it mean to say 6 is divided by 0? 6 is divided by 0. Is there a number such that when you multiply, is there a number here such that when you multiply it by 0, you actually get 6? No, because if you multiply 0 by anything, by default or by definition, that's a 0. That's not some other number. So we have a problem when it comes in dividing by 0. So in general lines, that is why division by 0 is undefined, generally speaking. Okay, so here's another property. If you say that a number times some other number is equal to 0, it means that one of the two numbers must be 0. Then either A is 0 or B is 0. If multiplication of two or more numbers equals to 0, that one of the two or one of those must be actually 0. Okay, properties of operations of fractions. Properties and operations of fractions. Fractions. All right. So let's say a number divided by another is equal by some other number divided yet by a fourth number. So it is, if it is given to you that these two fractions are equal to one another, this is the same as cross multiplying. So this is true if and only if this other thing is true. A times B is equal to B times C. Cross multiplication, A times D is equal to B times C. So we say that these two fractions are equal to one another if and only if this other thing is true. Okay, so here's another one. Minus A over B is the same as A over minus B is the same as minus A over B. Just like we talked about the association of the negative sign in a multiplication before, same idea here. Whether you associate this negative sign with a numerator or denominator or the whole fraction in general, it's exactly the same end result. It's exactly the same thing. So, whereas um, whereas a negative number over another negative number is the same as the ratio of their positives. Okay. Uh, Yet another one. A over B is equal to, so if you have a fraction, it's okay. The value of the fraction will not change if you multiply top and bottom by the same thing. So the ratio A over B is the same as the ratio A times C over B times C, provided that C certainly is not zero and B is not zero. So if you are given a fraction, it's okay, or the value of the fraction will remain the same. The value of the ratio will remain the same if you multiply top and bottom by the same thing, as long as that thing is not zero, and of course, as long as your denominator is not zero, because division by zero is undefined. All right, so here's an example. 4x over 3y. It is the same as 4x times 2 over 3y times 2, and the value of this ratio is the same as 8x over 6y. So 4x over 3y, that ratio is exactly the same as the ratio 8x over 6y. Okay, so moving on. And this is a property that most students, unfortunately, are confused by. How do you add and subtract two fractions that do not have the same denominator? So here's the rule. If you have A over B and you're adding or subtracting to that C over D, where B and D are very different, this is the same as doing the following. You multiply B and D together, B times D. Then you multiply A by D and you add or subtract C multiplied by B. Okay. Uh, Also, it's very easy to add or subtract two fractions that have the same denominator. This is simply adding or subtracting the numerators, and the denominator stays the same. All right, so let us do examples. 2 over 3, for example, plus 5 over 4. According to the rule that I have on the top here, the common denominator, so 3 and 4 have nothing in common, but so the common denominator must be their product. So 3 times 4, I multiply 2 by 4 and I add 5 times 3 according to the rule that I have written above. So that is 8 plus 15 over 12, or 23 over 12. And an example with the same denominator, 1 over 5 minus 3 over 5. You add or subtract simply the numerators and you keep the same common denominator. In this case is 5. Y minus 3 is the same as minus 2 over 5, and that is the same as 2 over minus 5, or the same as minus 2 over 5. All right, moving on, multiplication of fractions. How do you multiply two fractions? So A over B times C over D. Uh, do not confuse this with cross multiplication. Cross multiplication happens if you have two fractions that are equal to one another. You don't cross multiply if you have to simply multiply two fractions. So if you have to multiply two fractions, you multiply the numerators and you multiply the denominators. And that's that. For example, 2 over 3 times 1 over 9 is the same as 2 times 1 over 3 times 9, or 2 over 27. You do not cross multiply here. Do not confuse that. Do not confuse that. Of course, here B and D must not be 0. Okay? How do you divide two fractions? A over B divided by C over D. Uh, this is the same as saying take the top fraction or the first fraction and multiply it by the reciprocal of the bottom fraction or the second fraction. So this is the first or the top. I'm taking the first or the top and I'm multiplying by the reciprocal of the second or the bottom. And then now this becomes just a multiplication of two fractions. So by the above rule, I should have A times D over B times C. Keep in mind, that's another way of saying A over B divided by C over D. So that's the same as taking the top fraction and multiplying by the reciprocal of the bottom function. Obviously here, B, C, and D should not be 0. So here's an example. 3 over 5 over 1 over 4. That is the same as the top fraction being multiplied by the reciprocal of the bottom function. Now this is simply the multiplication of two fractions, so I do multiply numerator and numerator and denominator and denominator. So that is simply 12 over 5. Okay, now we come to a more involved concept of polynomials and factoring. So I'm going to define what a polynomial is in general terms. And then I'll give some examples and then we go into methods of factoring. Some methods of factoring that you have learned in college algebra. I will not talk about all of them, but it is a good idea that you review them from the very first chapter in the book, not chapter number 1, but chapter P. It reminds you once again, or reviews once again with plenty of examples, all common methods of factoring, which I shall mention rather briefly now. Okay, so let us talk about polynomials and factoring. Okay, so here's the definition of what a polynomial is. A polynomial is the addition of a bunch of terms. But these terms surely do have a pattern that we should recognize, and we have a name for this. So here's a definition. The definition is nothing new, but the notation maybe is new to some of you. I don't know how you have been exposed before to polynomials, but this is a definition that hopefully by examples you should all recognize. Uh, you all have seen polynomials, so let me just define that. Okay, so a sub n times x to the power n plus a sub n minus 1 times x to the power n minus 1 plus a bunch of terms where the term before the last should be a1x and the last term is a0. So let me tell you what these a's are, where, so the subscripts don't really mean anything. The numbers a n, a sub n minus 1, and so on, a sub n minus 2, all the way to a sub 1 and a0 are simply some numbers. Uh, the, the subscript here means that this coefficient is associated with the term that contains x to the power n, where n is actually the highest power of x that occurs in the polynomial. But let me just write this. Where a n, a sub n minus 1, uh, a sub n minus 2, and so on, all the way to a1 and a0 are simply any real numbers are any real numbers and the leading coefficient, or that a sub n is not 0. These are called coefficients. X is the variable, meaning what we're solving for, the quantity that we don't know. And n is the highest power of x. N is called the degree of the polynomial. And the polynomial written in this form is called a polynomial in standard form. It's called polynomial in standard form. Okay. Of course, also an is called the leading coefficient. Okay. So here are some examples. Let's say you have 2x plus 1. First, let's see that the term that contains x is just this, 2x. If x does not have a power, it is assumed that x has power 1. So since x does not have any other power on the top, it means that the highest power of x is 1. So this is a polynomial of degree 1. So here, and the number that is associated with x in the highest power is the number 2. So 2 is your leading coefficient, or your a sub n. So here, your leading coefficient is 2. Degree of the polynomial is n equal to 1. And since the constant coefficient, you see in this definition, a sub 0 is a coefficient that doesn't have any x attached to it. So it's the constant coefficient, otherwise known as the constant coefficient, meaning the number that is not associated with an x. In this case, a sub 0 is 1. Okay, let's take another example. X to the power 2 minus 2x plus 5. So the terms that contain x are x to the 2 and 2x. The highest power of x is 2. So this is a polynomial of degree 2. The number that's associated with x to the 2 is 1. If you don't see anything in front of x, it is assumed that x squared is multiplied by 1. So the leading coefficient is 1. So let me just write this down. The leading coefficient is 1. The degree of the polynomial is 2. The coefficient after the leading coefficient will be the next one, which is minus 2. A sub n minus 1 would be the coefficient that is attached or associated with the x that is of the power 1 less than the degree of the polynomial. The degree of the polynomial is 2. So the next term that contains an x should be in the power 2 minus 1 or 1. So this is the term. And the number that's associated with that x is the number minus 2. That's why we say the next coefficient after the leading coefficient. If the leading coefficient is a sub n, then the next one will be a sub n minus 1. That is minus 2. Okay? And the constant coefficient here is 5, because that's the number that is not associated with any x. What about this? Before we talk a little bit about this, note that this is the same as writing 3x to the power 2 plus 0 times x to the power 1 plus 11, right? These two statements are the same. Why? Because 0 times anything is equal to 0, and we usually don't write that. So just because it's missing there does not mean that it doesn't exist as a coefficient. So having said all that, the highest power of x here is 2. The number that's associated with x to the power 2 is 3. So the leading coefficient should be 3. Degree is still 2. The number that's associated with the x that is 1 less than the degree, which is 1 in this case, x to the power 1, is 0. So the next coefficient, a sub n minus 1, is 0, and the constant coefficient is 11. Okay, so let us do some more examples until you get comfortable with realizing whether you have a polynomial in the standard form or not, and identifying the degree, leading coefficient, constant coefficient, and so on. So some more examples. Minus 5 x to the third plus 2x to the 2 minus 11x plus 2. Okay, so leading coefficient here, well, let us start with degree here is 3 because that's the highest power of x. Degree n here is equal to 3. So the number that is associated with x to the power 3 is 5. Not 5, it's minus 5. So your leading coefficient is minus 5. That means your a3, because 3 is the degree of the polynomial, so your leading coefficient is a3, and that's equal to minus 5. The coefficient after that, which is a2, is the coefficient that is associated with x to the power 1 less than the degree, meaning x to the power 2. And the coefficient that's associated with that is simply number 2. Okay, then the coefficient that is related to x to the power n minus 2, or 3 minus 2, or 1 in this case, is minus 11. And a0 is just 2. Okay, here's another example. Minus 11x to the 3 plus 15x, and that's it. So let's see. Keep in mind, this is the same as writing minus 11x to the 3 plus 0 times x to the 2 plus 15x plus 0. Okay, so that's more of a standard form than you see it here. So if you rewrite it in this form, then you can, at least in the beginning, then you can say what's what. So the degree here, it's still 3. The leading coefficient, or a3, is minus 11. a2 is the one that is associated with x to the power 2, is 0. a1 is the one that is associated with x to the power 1, is 15. And the constant coefficient that is not associated with any x is just 0 in this case. Do you actually have to write it this way for you to realize what's what? Absolutely not. As long as you know that just because they do not show up on your polynomial does not mean that we cannot talk about these other coefficients. So as long as you realize what's what, it's okay. All right, here's another example. 2x to the third minus 2x to the 2 plus 5. Okay, again, this is the same. You don't have to do this, but we'll do this. This is the same as writing 2x to the third minus 2x to the 2 plus 0 times x to the 1 plus 5. So degree is still 3. Leading coefficient, or the coefficient that's associated with x to the 3, is 2. The coefficient that's associated with x to the 2 is minus 2. The coefficient that is associated with x to the 1 is 0. And the constant coefficient is 5. All right, so much for that. Let's talk a little bit about the product of polynomials, specifically the product of binomials. What are binomials? Binomials are terms, it's addition or subtraction of two terms. Binomial. Monomial is just one term. Binomial is a polynomial, but you're adding or subtracting two terms. Trinomial is the addition or subtraction of three terms. Poly in Greek means many, so the addition or subtraction of many terms. That's what we mean by a polynomial. All right, so product of polynomials. Okay, you have seen those, specifically product of binomials. Again, addition or subtraction of two terms. Binomial is a polynomial, but just with two terms. All right, how do you multiply two binomials? So that is the famous FOIL, which you have learned before. So if you have to multiply, let's say A plus B times C plus D, what is this FOIL FOIL method that we're using? Okay, the letter F stands for first, first terms. The first terms are A and C. So A times C. You multiply the first terms. Then you add the outer terms. The outer terms are A and D. So these are the outer terms for this binomial. A and C are the first terms, A and D are the outer terms. I stands for inner terms. So the inner terms is the B and the C. So you keep adding B times C. And L stands for less terms. The less terms are B and D, plus B and D. So first term multiplied plus outer terms multiplied plus inner terms multiplied plus outer terms, not outer, less terms multiplied. Okay. First, outer, inner, last, FOIL. Okay. We'll be using this a lot throughout this course, so make sure that you are comfortable enough with multiplying binomials and executing the so-called FOIL. Here's an example. Um, 3x plus 2 times x minus 1. Okay, so the first terms are 3x and x. The outer terms are 3x times minus 1. The inner terms are 2 times x. And the last terms are 2 times minus 1. Okay, so let's work this out. 3x times 3x times x is 3x squared. 3x times minus 1 is minus 3x plus 2x plus 2 times minus 1 is minus 2. We combine like terms here. The like terms are minus 3x and 2x. So 3x squares, 3x squared goes along for the right. Minus 3x plus 2x is the same as minus x minus 2. So that's the end result of doing FOIL. Okay, so what are some special products? If you do the FOIL to the following products, you get the following formulas. Um, it's important that you remember those and you recognize them when you see them in various algebraic manipulations. So what are some special products? Okay, so x plus y multiplied by its conjugate. What do I mean by a conjugate? A conjugate of an expression is exactly the same expression, but with the sign reversed. So if x plus y is an expression, then its conjugate expression would be exactly the same thing, but with a minus. So x plus y times its conjugate. If you do the FOIL correctly, you will end up with x squared minus y squared. X plus y squared, if you do the FOIL, that's the same as saying x plus y times x plus y. And if you do the FOIL correctly, this is equal to x squared plus 2xy plus y squared. Similarly, x minus y squared is the same as x minus y times x minus y. Again, if you do the FOIL correctly here, you'll end up with the following formula: x squared minus 2xy plus y squared. I'll keep referring to these formulas throughout the semester, so know where they come from and try to remember these formulas. Okay, so x plus y to the power 3. If you do the FOIL here more than once, because you have three products being multiplied to one another, you will end up with the following formula: x to the third plus 3x squared y plus 3xy squared plus y to the third. Okay, and x minus y to the third is x to the third minus 3x squared y plus 3xy squared minus y to the third. All right, here are some examples. So a lot of times, you might be given expressions that look like this, and your job is to realize that they are nothing else other than expressions on the left hand side, and vice versa. So knowing or remembering these formulas come in very handy throughout. It will be very handy if you know them throughout the semester. All right, here are some examples. Okay, let's see. 3x minus 2 times 3x plus 2 is nothing other than like the first model, an expression times its conjugate. So an expression times its conjugate is equal to the difference of two perfect squares, where these squares are the square of the first term, the square of the second term. So this is the square of the first term minus the square of the second term, and that is 9x squared minus 4. What about x plus y minus 3, x plus y plus 3? This is also the multiplication of two conjugates. Think of x plus y as one term, So x plus y minus 3 times x plus y plus 3. So it's almost the same, except with this minus here. So you may think of those as the multiplication of two conjugates, where the first term is x plus y, so x plus y squared minus the square of the second term. So do I have a formula for x plus y squared? I do. It's right here. So this is equal to x squared plus 2xy plus y squared minus 9. Okay. And here's another one. 5 plus square root x times 5 minus square root x. This is also the multiplication of two conjugates. So the first term here is 5. So you take 5 squared minus the square of the second term. The second term is the square root of x. 5 squared is 25. The square root of x squared is just x. And that's that. All right, now almost the last part of the review, and you have to do a lot of work on your own on this part, as there are several ways of factoring expressions that will come in handy. I'll just talk about two of those, and then you can review the other two. So factoring. One way of factoring an expression is by finding and or removing the common factors. What do I mean by that? Let's say that you are given 4x plus 6. Uh, Here we'll make use of the distributive property that I talked about at the beginning of this lecture. So do 4x and 6 have anything in common? They do. They have number 2 in common. So you can pull that number 2 in front. If you divide 4x by 2, you are left with 2x. If you divide 6 by 2, you are left with 3. So now, that's what I mean by bringing or finding or removing or bringing the common factor in front and multiplying with whatever is left. By whatever is left, I mean whatever is left once you divide those terms by the common factor. So now if you distribute this, meaning 2 times 2x gives you 4x and 2 times 3 gives you 6. So by the distribution property or distributive property, the right-hand side is equal to the left-hand side. Okay, here's another way. Factoring special polynomial forms. By special polynomial forms, I mean recognizing that you're dealing with one of those special forms, whether you are given the right-hand side of that or the left-hand side of that. Okay, so factoring special polynomial forms. Okay, so let's say that you are given x squared minus 49 and you are asked to factor that. Notice first that x squared is a perfect square, meaning it's the square of something. Is 49 the square of something? The answer is yes. Is the square of 7. So you can write this as x squared minus 7 squared. So basically you are given the right-hand side of something that looks like this. X squared minus 7 squared, according to this special product, it should be equal to x plus 7 times x minus 7. So this is equal to x plus 7 times x minus 7. All right, here is another one. 3x times x plus 2 minus 4 times x plus 2. Do these terms have anything in common? The answer is yes, they do have x plus 2 in common. They have this binomial as a common factor. So you can pull that out in front. So x plus 2, when you divide 3x times x plus 2 by x plus 2, you are left with 3x. When you divide 4 times x plus 2 by x plus 2, you are left with 4. So that's another way of factoring this expression. All right, what about the next one? 2x to the third minus 8x. All right, the first thing you should typically try is to see if there are any common factors, unless it is something as obvious as this being the difference of two perfect squares. This doesn't look like the difference of two perfect squares, but looks like 2x to the third and 8x contain something in common. What is that common factor you think they have? Well, 2 and 8 have 2 as a common factor. X to the 3 and x have x as a common factor. So the common factor of both should be 2x. When you divide 2x to the third by 2x, you are left with just x to the 2. When you divide 8x by 2x, you are left with 4. You're not done factoring because this is in fact the difference of two perfect squares. So you can keep factoring further. Leave the 2x alone. Now x squared plus 4 is the difference of two perfect squares, meaning it is the same as x minus 2 or x plus 2 times x minus 2. And now this is completely factored. You cannot factor this anymore. So on your own, you should explore factoring by grouping or factor by grouping. And using, once you group, then you can use either polynomial forms or common factors. So you will recycle the first two methods. Once you group certain terms that are convenient, that is, and look for trinomials with binomial factors and practice a little bit on those. Okay. So, as I mentioned at the beginning of the lecture, plenty of those examples are in chapter P, which you should take some time and carefully review before we start with the new material for this course. It is very important that you are comfortable enough with your algebraic skills. Okay, everyone, so long, and I will see you next time. We'll start with the first lecture for this pre-calculus course. Until then.